Welcome back, learners! In this video, we're going to do integration by parts. So this method teaches us how to use the u that will make our solution shorter. So it says late, L for logarithmic, A for algebraic, T for trigonometric, and E for exponential. So there is an arrangement here. It means that the first to appear is the one that you will choose to be your u. For example, earlier, if you remember, we had the integral x sine x dx. So this is the integral of the product of x and sine x with respect to x, right? So x here is an algebraic term, while sine x is a trigonometric term, right? So we have an a and at, and based on LATE, a appears first, right? Before t. So this a here, the algebraic one, the x1, is the one that we will choose as u. And of course, the remaining will be your dv, because we want this to be written as the integral u dv. And then, just previously, we had our example, the integral x squared ln x dx, where x squared is algebraic, right? And then the ln x is logarithmic. This is under the logarithmic. You see the logs, the ln's, those are the logarithmic terms. So L. So between these two, algebraic and logarithmic, according to this late method, L appears before A, right? So the ln x should have been chosen as the u. And the x squared dx, this part here, x squared dx, should be the one chosen as our dv, because multiplication is actually commutative. We can actually write, instead of integral x squared ln x dx, we can write this as the integral ln x squared dx. Right? If you really want to make this have the same pattern as the integral u dv, where u comes first before the dv, so you can do this. Now let's go ahead and try that. Let us remember though that the answer that we got earlier for this was x cubed ln x over 3 minus x cubed over 9 plus c. Let's see if we'll get the same answer. This time, let us choose ln x as our u. And the remaining, which is x squared dx, will be our dv. Now let's find the derivative of u and the integration of dv for the other needed details. So we have the derivative of u is 1 over x dx, while the integral dv is equal to the integral x squared is equal to, this actually has dx here, x squared dx is our dv. So the integral x squared dx is x cubed over 3 plus c. But then again, this is the part that we will only need. So we have the integral ln x squared dx equals, applying our uv. So u is ln x, our v is x cubed over 3, minus the integral, again the v is x cubed over 3, and the du is 1 over x dx. So let us simplify this first. We have x cubed ln x over 3 minus, let's bring out the constant here, which is 1/3. And as you can see, we can simplify x cubed over x, leaving us with x squared only. So the integral what's this? X squared dx, right? And finally, we have x cubed ln x over 3 minus 1/3. The integral x squared is x cubed over 3, right? And then the plus c there. And we have x cubed ln x over 3 minus x cubed over 9 plus c. Yay! We got the same answer as the previous one, right? And as you can see, our solution is way shorter than the previous solution. So the late method is great, right? Now let's have our next example, the integral x cubed e raised to x dx. And now choosing the correct u, x cubed is algebraic, e raised to x is exponential, right? And in our technique LATE, a appears before e. So we will choose x cubed as our u. Therefore, the remaining e raised to x dx will be our dv. So we have dv is e raised to x dx. And now let us get the derivative of u and the integral dv to find the remaining details. So we've got du is 3x squared dx, while for v, the integral e raised to x dx is just e raised to x plus c, right? And we use this part as our v. Now we have complete details for use. We have equals uv, so that's x cubed times e raised to x minus the integral e raised to x 3x squared dx. And simplifying this, we have x cubed e raised to x. Let's bring out the constant. Minus 3 minus e raised to x. Then we'll have x squared dx. And as you can see, this is another integration of a product of two functions, right? So we will apply another udv here, or integration by parts here. So we have equals x cubed e raised to x minus 3. Let's use a different color for that. So for our integral e raised to x squared dx, so let's choose the u again is the algebraic one that appears before the e, the exponential, right? So we'll have u is equal to x squared, where du is equal to 2x dx, while the remaining, which is x squared dx, will be the dv. So dv there, and then get the integration of both sides to find the v. We have v is, what's the our dv is the remaining e raised to x dx, sorry. So that should be e raised to x. And the integral e raised to x dx again is e raised to x plus c, where we only get this. So let's have our u dv here. We have u, which is x squared, v is e raised to x, and then minus the integral v du. So v again is e raised to x, our du in this case is 2x dx. There. And then we simplify this. Can we really simplify this already? We have x cubed e raised to x minus 3. We are yet to apply simplifying first. X squared e raised to x, we bring out the 2 here outside the integral symbol, so minus 2. Then we have the integral e raised to x, x only, because we brought the 2 outside the integral symbol there. But as you can see, this is another integration of a product of two functions, e raised to x dx, right? So let's do another udv. So for our integral e raised to x, x dx. Let's choose the u, the algebra of course, before the exponential. So if our u is x, then du is obviously dx, right? And then again, the remaining e raised to x dx is the dv. E raised to x dx, and again, get the integral or integration of both sides. Then we have the v is e raised to x plus c, and again we only take this. So we have, let's do this step by step. X cubed e raised to x minus 3, let's retain the color. X squared e raised to x minus 2. Then we use the blue one for this. Another uv minus integral v du, right? So u in this case is x and v is e raised to x minus the integral v du. So again, v is e raised to x. And our du is the dx already there. So I think we are almost at our final answer. So we have x cubed e raised to x minus 3, and then x squared e raised to x minus 2, and then x e raised to x, and we can actually get this part already. The integral e raised to x dx, which is e raised to x plus c, right? So we just have minus e raised to x, and then the plus c at the end. Let us not forget that there. So let us simplify this. What do we do first? The one inside first, right? So we distribute the 2 here. Therefore, we have equals x cubed e raised to x minus 3, and then x squared e raised to x. Now the distribution, minus 2x e raised to x, and then becomes plus 2e raised to x, right? And of course the plus c here. Next that we do is to distribute now the negative 3 to all of these 3 terms here. So we have x cubed e raised to x minus 3x squared e raised to x becomes plus negative plus 6x e raised to x minus 6 e raised to x plus c, and we're done. Wow, for this one, we actually applied the UDV or integration by parts 3 times. So learners, what would you like to learn next? Comment below.